there is a minor correction in the question given here. So it says a lift of mass m is equal to 500 kilogram is descending with speed of 2 meter per second. Its supporting cable begins to slip, thus allowing it to fall with a constant acceleration of 2 meter per second square. Find the kinetic energy when the tube comes to a fall of distance of 6 meter. See, let me take some time to, you know, to emphasize on this phrase here, which is begins to slip. It's really important that we understand each and every phrase given in the question, because there is always a concept hidden, behind these phrases given in the question. So, when we say that the cable supporting the lift begins to slip, okay, it implies a change in the interaction. Let me just highlight this. Begins to slip. It implies a change in the interaction between the lift and the cable due to reduced friction or loss of grip. This change results in relative motion between the lift and the cable. If we consider VL to be velocity of the lift and VC to be velocity of cable, before slipping, velocity of lift is equal to velocity of cable, which means the lift and cable are traveling together, right? Which means I'll just in a minute I'll take you to the diagram. So this is lift, okay. So that is the cable. This is the cable, and then we have here the lift. When the velocity of cable is equal to velocity of lift, the relative velocity between them is velocity of lift with respect to cable is equal to velocity of lift minus velocity of cable. Since both of them are equal, this would be equal to 0. However, after slipping, what happens is relative motion comes into picture, which means the lift and the cable are now traveling at two different speeds, and therefore velocity of lift with respect to cable is not equal to 0. So before slipping, the lift was descending at a constant speed. Now what has happened? Now it is no longer at a constant speed. In fact, it is coming down with a net downward acceleration of 2 meter per second square. Okay, so this is what I wanted to understand, because it's really important that that we always try to understand each and every phrase that is given, because when you get such a clarity in the question, things will become really easy for you to calculate and understand, most importantly. So now what we'll do is we'll go into the numerical part here. But before that, let us just visualize this portion here. So we have VL is equal to VC, which means before there was no slipping, right? Before there was slipping, the no slip condition, velocity of the lift, right? Velocity of the lift here will be equal to velocity of the cable, because they are traveling together. So velocity of lift VL is equal to VC. And when slip occurs, there is somehow a loss of contact between the cable and the lift, right? So the lift is now free from the cable, and velocity of lift will definitely not be equal to velocity of cable. And it is given to us that this lift is coming down with an acceleration equal to 2 meter per second square. Okay, and it is also given that after slipping, the distance traveled by this lift is 6 meter, and we've been asked to find out the velocity of this. We've been asked to find out the kinetic energy of this lift at the end of this 6 meter. Okay, so at this point, the lift was coming with velocity u is equal to 2 meter per second. Then it has been under the influence of acceleration. We've been asked to find out the kinetic energy at this point, which means we'll have to first find out the velocity at this point, right? And then we have velocity square into m by 2 will get the answer. Now, to do that, what we'll do is we'll make use of the kinematic equations of motion, right? So what is the initial velocity given to us as? It is given to us as 2 meter per second. What is the acceleration given to us as? It is given as 2 meter per second square. And it is given that the lift has traveled 6 meters. So by displacement time relationship, we have v squared minus u square is equal to 2as. U is 2 square. Then we have a is 2, so this becomes 2 into 2, 4, 6, 24. 24 plus 4 is 28. And once we get the value of v square, right? Once we get the value of v square, kinetic energy would be equal to half m into v square. Half m into mass of the lift is given to us as 500 into 28. 28 by 2 is 14. 14 into 5 is 70. 70 followed by 2 zeros. 70 followed by 2 is 7,000 joules. Now, this is one point where, for the while I was doing for the first time, my answer was wrong. I do remember this because see, this is an integer type question and you need to feed in an answer, and the answer here is expressed in kilojoules, which means 7,000 joules can be written as 7 into 1,000 joules, and 1,000 joules is kilojoule. Therefore, the answer here would be 7 kilojoules. Okay. All right. So that's it with this question. Let us move on to the next one.